Okay, this is, I think, going to be our final video. First thing that I want to talk about is polls. And polls are supposed to follow all the same rules that we've been talking about up till now. They have to be representative. They have to uh, uh, have enough, be big enough to contain enough diversity. I'll get it right eventually. So everything that I've talked about up till now has to be done in a poll, or the poll will not be valid. So a poll depends upon a representative sample, just the way we did with the number of Democrats for teachers. Now, one thing that you need to know is that a self-selected sample makes for an invalid poll. Okay, why is that? Well, let's say that CNN decides to have people call in and say whether they like Donald Trump or don't like Donald Trump. And if you call in, you can express your opinion one way or the other. So normally what will happen in a situation like that is CNN has a very large audience, but only a small number of them will actually take the time and trouble to call in. And so what we'll end up getting is a sample made up of people who really, really dislike Trump, or who really, really like Trump. And so the sample will not be representative, because there's lots of people who won't call in. Maybe they're too busy, or maybe they don't really care, or whatnot. In other words, but the sample will not represent the electorate as a whole. So a sample, or a self-selected sample, is never a representative one. So any poll that has a self-selected sample should not be taken very seriously. Now, to illustrate this, is that all of you, I'm sure, know about the Rate My Professor website, and that you can go there and see how other students rate their professor. And for example, you can do that with me. I'm listed on that. And what you end up with is people will upload their information, their opinion, one way or the other, if they feel pretty strongly about it. Maybe a student doesn't like me, I gave them a bad grade, whatnot, and so they upload their view that I'm no good. And then maybe there's some other students who like me, and they put that down in the Rate My Professor. And so what you end up with is, just like with the Trump poll, you end up with some people who don't like me, and some people who do like me, and the proportion between the two is not representative. Maybe there's a lot more people who don't like me than do, or maybe there's a lot more people who do like me than don't. But in any case, the results of the poll are of the sample are not representative. And this is not just the case with me, it's the case of any type of poll that bases the sample on people who choose to include themselves in the poll, or a self-selected sample is what we call that. And so they aren't very good polls. Okay, we're going to talk about playing by the numbers. And I think most of you probably know that the odds on when we flip a coin, the odds that it will be tails are the same as the odds that it will be heads. That will come out exactly the same. In other words, for every head, you should also get a tail. However, when we start flipping the coin, it's possible that we may end up getting a lot more, let's say, heads than tails, or tails than heads. And this is not unusual at all. And many people think, well, if you get 6 or 8 tails in a row, it's due to have a head. And that's the wrong way of thinking about it. Every time that we toss the coin, it's going to be 50-50. 50% chance of heads, 50% chance of tails. And each time that we flip the coin, it will have those same odds. So the results of flipping the coin many times is not to rebalance itself, but it's represent the odds for each flip. That when you flip the coin, let's say, and it comes up heads, the next flip, that the coin will have no information about that. It will just flip itself at heads or tails, 50-50. So the odds stay the same. There's no rebalancing. If you flip the coin many, many times over a period of time, it will even out. It will come up 50% both ways. The more times we flip it, the more times, or the better the results will be in terms of its odds. Now, there's a fallacy related to this, and that's called the gambler's fallacy. And then that if you go to Las Vegas and you're going to gamble, and let's say you're a very, very big gambler, and you've been playing roulette, and you have been losing steadily. And the odds, I think, in roulette are 1 to 36. I may be off on that, but let's assume I'm right. And so each time that you play the game, the odds are still 1 in 36. If you lose 10 times in a row, the next time you play it, the odds are still 1 in 36. The gambler's fallacy is that, eventually it'll swing back the other way, and it doesn't do that. Each play in this example is 1 through 36. So the gambler's fallacy, the reason why it's a fallacy is because it's not true. And of course, the best choice to make is to not bother gambling at all. Okay, the last thing that I want to talk about it's called the principle of total evidence. And so let's say that we're going to make an inductive argument, and we have some evidence that we use for our conclusion that we have. Let's say we're going to bet that the 49ers are going to win a particular game. So we look at the quality of the 49ers and the quality of the opposition, and we compare players and who's injured and so forth, and we go on and on and on, and we include many factors into the premise, and then the more factors that we include, the stronger the premise, the stronger that the conclusion will be. In this case, let's say that the premise leads us to the conclusion that the 49ers will win. Okay, now, is it possible that there might be some evidence out there that we didn't take account of? Maybe we don't know that one player is injured, or that the quarterback won't play, or that there could be any number of different things. Maybe one player is ill and we don't know about it. Okay, so that would mean that we don't have the total evidence. In other words, that according to this idea, the evidence that we put in our premise should be everything that is knowable. Okay, that's the principle of total evidence. And then based on the total evidence, we can reach a strong conclusion. Okay, so that's what some philosophers argue. They argue that you have to have the total evidence, and then you can make your conclusion. Okay, the problem with that is it could be that there's a lot of evidence that we don't know about and that we don't include it. We may think that we have the total evidence, and yet we don't. And so it seems to me that we rarely generate an inductive premise where we know for sure that we have all the possible evidence. And the philosophers who argue in favor of this principle of total evidence, that you have to have all of it before you reach a conclusion, logically, they would have to say that if we don't know all the potential total evidence, we are jumping to a conclusion. We don't have enough evidence to support our conclusion. In the case of the 49ers, we don't know everything about what's happening with 49ers, but we don't even know that we don't know that. And so the people who favor this principle would say that we are jumping to a conclusion, or we are making a hasty generalization. The problem with that is that we would never know for sure whether we have got the total evidence or not. And if we follow the rules of the principle of total evidence, then every single argument, inductive argument, would be reaching a hasty conclusion. So it's my view that the principle of total evidence is invalid, it's bogus, and that we should ignore it. All we can do is try to include as much evidence as we possibly can. So this is the end of my videos on induction. You need to read through the notes very carefully. There's some things in the notes that I did not cover in the lectures. Please take advantage of these lectures. I think you'll find them helpful. In any case, good luck.